Okay, this is the lecture for Module 9. It covers two topics, both of which are in Chapter 12 of the text, exception handling and file I/O. This will be fairly short because most of this is done using the sample code and walking through the examples. The code is available to you as part of these notes. These are the outcomes. There's only two, but they're fairly substantial. Using at a top level how to build the exception handling routines is pretty straightforward. Of course, becoming an expert at them, like anything else, you have to have experience with that. And then using the file I/O is not too difficult. We only worry about text file I/O in this class, not binary, not formatted data files. If you can do text, you can do the binary pretty easily. Writing to a file you'll find is easier than reading from, and that's because when you're reading from, you do have to worry about the format of the data that's in the file. Okay, so let's start with exception handling. The term you'll hear is try, throw, catch, and many programming languages use this, and the idea is you try something, and if it throws an exception or throws an error, then you catch it. And when you catch it, you actually write code to modify the behavior of the program to handle that exception. Usually you're going to warn the user about what's happened, or you warn the developer that something's gone wrong. But then you also may default to some standard values for an attribute, or maybe you'll allow the user to try some action again or something like that. So you're trying an action, throw an exception, and then catch the exception. The tries and the catches are both enclosed in curly brackets because that's how Java always encloses sections of code. So curly bracket to try something, curly bracket to handle something. You can have multiple catches for a single try because you can catch different kinds of errors, and I'll mention that several times in this talk. Okay, what kinds of exceptions are there? Now again, we say exceptions, you can think of error, you can think of program crashing. That's what an exception is. The ones that are most commonly found among students in this class are things like null pointer exception. That means that you're trying to work with an object you haven't created yet. You're trying to work with an array that you haven't created yet. Or an input mismatch exception. That's the one where the user is allowed to input freeform data. You were expecting one kind of data, they gave you another type. By the way, in terms of your project, you must have one Java exception that you wrote all by yourself that does not involve file I/O. An input mismatch exception is a really easy way to meet that requirement. File not found exception, you're trying to find a file that doesn't exist. And then, of course, array index out of bounds. And the reason that one's common is because that's one of the more common errors when people are working with an array, is they actually try to access something that's off the end of the array. You can and you should specify exactly what kind of exception you are looking for. So when you catch something, you say catch, but then you also specify the kind of exception that you're going to catch. And as I said, you can specify multiple types. The reason you'd want to do that is because you may have a different corrective action for each kind of exception that you got. Why do you use them? Well, in the Liang code, they build up the case for this through code examples. They have a division by zero sample. And division by zero, the first thing they do is they do nothing. Program crashes. That's bad. Then they do an if then else. If the divisor is zero, don't do the division. And that, of course, protects you. But if there's a zero in the denominator, it's likely that something went wrong. And so it would be helpful for you to tell either the user or the developer that something went wrong. So by using an if then else, you're actually alerting them to the fact that, hey, things aren't right. I mean, the program didn't crash, but something's fishy here. The next example is to perform the division in a method, which is similar to the if then else, and then they perform the division with a try, throw, catch, and that allows you to have corrective behavior. Now, they don't do any corrective behavior in the example, they're just showing you the different forms and lets you allow you to experiment with the different forms. Okay, when should you use an exception? Any point in a program when an error may occur. Well, that's everywhere, right? Well, there's certain portions of a program that are more susceptible to others. Free-form user input is a gimme. You should never have free-form user input without doing some kind of a validation of the input and verification that the types are right, and also to validate what they're putting in, which is a little bit beyond the scope of this course. It's actually a security issue. It turns out in some programming languages there are ways that people can just fill in a text field that allows them to actually cause your program to crash or access memory that you didn't intend them to access. So it can be a security issue. So validating the input is good. All we care about here is that if they put in a bad data type, let's say, that instead of having the program crash, you can catch it and correct it. Input parameters to methods that can cause errors. We've talked about how we had the circle, and we had a circle constructor example. So you had the circle constructor example, and we could put in a negative radius, let's say. And hey, the circle object was happy with that, right? It was fine with that. Well, maybe in your program, you really can't allow that. That really causes a problem. So maybe you have a negative radius put in for the circle. Instead of having the negative radius, you can fix that. Now, you could fix it with an if then else, but you could also fix it with a error handling message. Maybe you default to a radius of 1. Maybe, again, think about, it's not necessarily that a user put that in, some other portion of the code put that in. Well, if some other portion of the code put in a negative value for a radius of a circle, maybe there's an error there that needs to be fixed. Didn't crash the program, but it gives you bad results. So again, you're able to notify both the user and the developer something went wrong. File I/O is often used for exception handling because file not found is a big thing, right? So if you don't find the file, rather than crash the program, alert the user, maybe they can try again to fix the file name. It's so common that I do not allow that to be used to meet your requirement for the project. Your exception handling has to not be related to file I/O. And of course, the other usage is array usage, because out-of-bounds exceptions can occur all the time. In terms of your project, you only need to do one. In general, though, you want to code as defensively as possible. So if you're really creating high-quality, robust code, secure code, you're going to put in a lot of exception handling. In practice, wherever you work, they're going to tell you what their code quality guidelines are, what their standards are, and that's going to tell you when to use exceptions. Okay, so here's what it actually looks like in code. These are from the Liang code examples. These are available to you as part of these notes. I did not modify these codes, maybe a tiny little bit, but basically I did not modify these codes. And it looks just like I said. There's a try block and a catch block. So here's the try. You enclose whatever you're trying inside of the curly brackets, because that's how Java always designates sections of code. And here they had created a method called quotient. And previously they'd asked the user to put in number 1 and number 2. And the idea is if you put in a 0 for number 2, you should get an issue. So here's try. And then catch. And notice it's catch, but then you say what you're trying to catch. You're trying to catch an arithmetic exception. And the name of that thing that you caught, because it's an object, an exception is an object, the name of the thing that you caught is EX. Does it have to be EX? No. That's what's used in all the examples. You can name an object anything you want. And so instead of having the code just die here, where the quotient crashed because number 2 was 0. Instead, you just say, okay, exception in integer cannot be divided by 0, and then you go on your merry way. Now, again, here the author did not produce true corrective action in the code. They just saved it from crashing and then carried on, printed out a warning message and then carried on. You are allowed to throw your own error. Look at that, throw. Throw new exception. An exception is an object, so you created a new exception object. You're allowed to throw your own exception. And if you do that in a method, the method has to say that the method throws an exception. So now we have public static void method 2. Boy, I hate that the author uses static methods, but oh well. Public static void method 2 throws exception. So if you're going to have where you create your own exception, that's how you have to do it. Now, why would you do that? For the exact case I talked about earlier, let's say you're doing an aircraft simulation and you're going to allow the aircraft to go from, an altitude of 0 feet to 60,000 feet, and someone tries to slip in a negative 10,000 foot altitude. Well, that's not a type error, right? That's not going to be a type mismatch, so it won't cause an error, but you clearly don't want that as part of your program, so you're allowed to verify, okay, is the altitude of the airplane between 0 and 60,000 feet? If not, you can throw your own exception. So if there are situations in your code where the code won't crash but it's wrong, you can actually throw an exception, and basically what you would do besides throwing the exception, you would have corrective action taken. Maybe that aircraft that was at negative 10,000 feet, you just switch the sign to plus 10,000 feet. Maybe you reset it to sea level. The idea is you have options, and you're aware that there was an issue. Here's an example where the author encloses a try, throw, catch, and a do loop. So they ask you to input an integer, and no matter what you put in, if it's not an integer, it will just keep going through this loop and saying again and again, hey, you have to give me an integer. And then as soon as the user puts an integer in, then it works. Why does this work this way? Because you're trying, okay, give me an integer. They give me an integer. If everything worked out fine, let's see, continue input equals false, and so continue input. Now you've triggered your way out of that loop. If you are trying and they actually put in an integer, then this is the code, lines 10 through 17, that gets executed. But if they put in a non-integer, that includes characters, that includes punctuation marks, then an error will occur, but the error will get caught. Input mismatch exception error will get caught. And so now lines 20 through 22 execute that just say, hey, try again, and it asks for the input again, and then it just keeps this while keeps you in the loop until the thing works properly, until the continue input is equal to false. But since if they didn't put an integer in, only lines 20 through 22 are performed, the continue input will still be true. Not the best way to use logic, but it shows the... Okay. No, didn't we do this? We already did that. Okay. Okay. File I/O is a little more straightforward. In File I/O, it's kind of like you've already got experiences with the scanner and with system.out. With File I/O, you just have to do a couple things. Here's their example for write data, and again, I'm going to do separate lectures with the actual walking through the code examples, running the code, and playing with it. But here's the write data example from the text. First, you create a file as an object. Now think about it. The file is actually stored on the hard drive, right? So what is this file object? It's a container. It's a reference point to grab hold of the file on the hard drive. So this scores.txt is the name of the file that the author's using, and sure enough, they've created a new file object that is basically, that's an object that acts as an interface between the Java virtual machine and the actual file on the hard drive. In order to write out to that file, remember, in order to get things in, you need to create a scanner. So in order to print things out, you need some kind of an outputter, and they're using a print writer. There are different forms of things that you can use to write to a file, and its name is output, and it's a new object, and you have to tell it what file you're going to use. So they create this file, scores.txt, the file object, and then they use that file object, which is again going to point to the physical scores.txt on the hard drive. And then the output is exactly like you've seen with system.out. System.out.println could be used here. Out.print, out.print, print. And when you run this file, you get a little scores.txt data file, which we'll play with in another lecture. To input data, this is the read data example, it's just similar. You create a file object. Now scores.txt here has to already exist. If it doesn't, you're going to get a file not found error. Because you're reading from the file, you create this scanner. And instead of, remember before you created a scanner and it was a system.in? System.in meaning the keyboard input, the console input. Now you're saying scanner, but now you're scanning from a file. So that becomes the input source. And then you do this cute trick. While the input has next, it turns out every file has what's called an end of file marker. So as long as you haven't reached the end of file marker, there must be something next. So the input has next is a good logical, a good Boolean test. While there's something still to bring in, keep bringing it in. But notice how they bring it in. It's a little different from how they printed it out. It turns out, let's go back. Here's what they printed out. John T. Smith as a single string. But when you're inputting, as soon as that white space shows up, that's brought in as one token. So you can't bring in John T. Smith, at least the way they're doing it, in a single line. There are ways to do it. They're not doing it this way though. So they're just saying input next. Input next doesn't mean the whole next line. It means the next string of characters until I see white space. So that's why they're doing first name, middle initial, last name, and then the last one is the score, but notice what they do differently. It's not input next, it's next int. Here's why. Every time you do input, it's considered to be a string, always. So that's the default, and that was true even when we were doing console input from the scanner. It's a string. So, input next, hey, it's a string that I'm bringing in. I'm already assuming it's a string. Next assumes it's a string. We're already type compatible, so it comes in as a string. But now for score, I want that to be an integer. So what I do is I have to tell it, hey, this next string, convert it to an integer for me. And then all we do is echo back what it does. So again, we'll play around with this with the examples. I believe in your lab you're going to have examples when you get to this lab where you're bringing in a line at a time. And that's a very common thing to do too, where you take a line in, it's still a string, and then you break it up once it's already brought into the Java virtual machine. In both of these, once you open a file, you should close it. So here our file, our print writer was called output, you close it. And for here, we had a scanner called input, and we close it. And the idea is you should always close your resources. If you leave them open, that can lead to a couple different problems, potentially a security issue where someone could grab it and grab that object and still get access to the data. But usually it's more about conflict problems. Somebody else needs to use the file, but you haven't given it up yet. Now, if you don't do the close statement, the Java virtual machine, when your program ends, will close everything out for you, but don't rely on that. Remember, always program defensively, program consciously, so put an explicit close statement in there. Okay, so now we're going to go and move into some using the code examples, and that will be the next lecture. And then, of course, we'll do this during the live lectures during the week.